Now we are going to see the meaning of SI and prefixes. What's the prefix? What is the meaning of SI? SI is called, or it is a short form for International System of Units, or System International D Units. When you say SI, it means System D Units, or this is a unit that works all over the world. It has acceptance. This is a unit which works all over the world. Scientists all over the world, they use the same units for the given physical quantities. They agreed to use the same kind of physical quantity or units all over the world. For example, they use a meter to measure the physical quantity length. Length is a physical quantity which is measured by its SI unit, meter. When you say SI unit, it is a unit that works all over the world. When you say meter, it doesn't mean that meter is only unit for length. We have other units, non-SI. We call them non-SI units, or units other than meter are called non-SI units. These are like centimeter, millimeter, kilometer, decimeter, a lot. We can use a lot. So this is, meter is the SI unit for length. Take mass. Mass is a physical quantity which is measured by the unit kilogram. The SI unit of mass is kilogram, which is symbolized by kg. But we don't mean that it is only kilogram that is used to measure mass. We can use other units. The other units are like, we have the other units which are called non-SI units. These are, we can also measure in grams or milligram. We can also measure in milligram. Let's take the time. Time is a physical quantity which is measured by its SI unit, second. Many students think that the SI unit of time is hour, but it's not hour, rather it's second. Hour is a non-SI unit. The non-SI units of time are hours, days, minutes, months, years, etc. So SI unit is a system of units that works all over the world, which has acceptance all over the world. It works all over the world. Scientists all over the world agreed to use SI system of units, that is System International D units. Each physical quantity has its own SI unit. Like for example, we can take also speed. A speed is the ratio of distance divided by time. It's the ratio of distance to time. So the SI unit of speed is derived from the units of time, and the units of distance, which is the SI unit of distance is meter. As I told you before, distance is length. I can write this as length divided by time. So the SI unit of speed is derived from the units of distance and the units of time. The unit of distance is meter and that of time is second. So meter per second is the SI unit of this speed. But we have other units. Speed can also be measured by, we can also measure by kilometer per hour, or meter per hour, or meter per second, and so on. But here what you have to is, scientists when are measuring the SI unit of a physical quantity, or when they are measuring a physical quantity, sometimes they use prefixes. They use prefixes. Whenever they are measuring physical quantities, they use prefixes. Prefix. So here you have to know what is the meaning of prefix. Prefixes are words or symbols which we put them in front of another word. Let's say example. If I have like, let's say we have a unit meter. If I add the word kilo, I get kilometer. So this kilo is called prefix. So prefixes are words or letters which are put or placed before another word. I can rewrite this as km, which is kilometer. Or take gram. Let's take the unit for mass, that's gram. If I add here milli, the word milli, now it becomes milligram, which is symbolized by mg. So this m and this k are prefixes. They are prefixes. So prefixes are symbols or words which are placed to right in front of another word. And here, why are we using prefixes? Why do scientists use prefixes? Prefixes are used to accommodate extreme values. Extremes. When you say extremes, so in, like for example, if the number is too big or too small, we can rewrite it by a word or a symbol called prefixes. So prefixes are used to write extremes. When you say extremes, we mean either very big number or small number. And the common prefixes are given here. I have prepared them in a table form. These are the common prefixes that we use in physics. Like here, 10 to the power of negative 18 has a special name called atto, which is symbolized by 10 to the power of negative 18 has a name called atto. It's a prefix which is symbol is a. The next prefix is, by the way, this is a very small number. 10 to the power of negative 80 means this is the same as 1 over 10 to the power of 18. It's a very small number. So this very small number can be written by prefix. Instead of writing this small number, I can use the prefix a, that's atto. The second prefix is 10 to the power of 15, negative 15, which has a name called femto, which is f. The other one is 10 to the power of negative 12, 10 to the power of minus 12, which is called pico. 10 to the power of 12, the name, this refers to a prefix called pico, that's P. The other one is 10 to the power of negative 9, which is called nano. The other one is 10 to the power of negative 6, called micro. Its symbol is a Greek word that looks like U, mu. It's a Greek word or a Greek letter called mu. The other one is 10 to the power of negative 3, which is equal to milli, which is small letter m. Next to this is 10 to the power of negative 2, which is centi, which is C. 10 to the power of negative 1, deci. These are, by the way, these are prefixes with negative exponents. These are what? Prefixes with negative exponents. All, as you can see, all of them have negative exponents. Negative 18, negative 15, negative 12, negative 9, negative 6, negative 3, negative 2. By the way, you have to know the meaning of 10 to the power of negative 3. This is the same as 1 divided by, I'm taking this because it's easy to explain and you can easily understand it. When you say 10 to the power of negative 3, we mean that this is the same as 1 over 1000. And this is the same as 1 divided by 100. And this is the same as 1 over 10. And this is the same as 1 over 1 million. Micro means 1 over million, or 10 to the power of negative 6. So all these prefixes have negative exponents. And there are also prefixes with positive power or with positive exponent. We can take the positive of these powers. For example, here 10 to the power of negative 1 is called deca. This is 10 to the power of negative 1. When the exponent is 1, it is 10 to the power of 1, which is called deca, and it's abbreviated as, it's shortly written as dA. Deca is dA. 10 to the power of 1, I hope you know it, 10 to the power of 1 is the same as 10. Any number with exponent 1 is the number itself. Like if you have 5 to the power of 1, it means 5. If you have 10 to the power of 1, it means 10. If you have x to the power of 1, it is x, the variable x itself. And the other one is actually, there is here, you can write deca, there is here deca. If you go, you can add, if you like, 10 to the power of 2, which is called deca. And the third one, the next one is 10 to the power of 3. It means you multiply 10 3 times. I hope this is from your mathematics background. I hope you know that 10 to the power of 3 with exponent 3 means you multiply 10 3 times. You know that the exponent tells us how many times the base is multiplied. This is called exponent and this is called the base. And the exponent always tells us how many times the base is multiplied. When you say 10 to the power of 3, we mean we have to multiply the base 10 3 times. That is 10 multiplied by 10 multiplied by 10, which is 1000. So this exponent or this power has a special name called kilo. Kilo is a prefix which refers to 10 to the power of 3 or 1000. 1000, or which is the same as 10 to the power of 3, has a name called kilo. The other is 10 to the power of 6, which is 1 million. 10 to the power of 6 is the same as you multiply 10 6 times. 10 to the power of 6, it means 1 million. You multiply 10 6 times and you get a million. And it has a special name called mega. Mega is bigger number. It's a very big number. As I told you before, prefixes are used to write extreme values or extreme numbers. Numbers which are very big, like kilo, mega, giga, tera, or smaller numbers like femto, pico, nano, micro. So 10 to the power of 6 has a special name that is called mega. Next is 10 to the power of 9, which is you write 1 and 9 zeros, and it has a special name called giga. If it is 10 to the power of 12, we call it tera. 10 to the power of 15, peta. 10 to the power of 18, exa. So these are the common prefixes that we have. Now let's see examples how we express numbers which are given in in 1 unit. If you want to convert it to another unit and express it by using these prefixes. Let me show you, let me give you example on this. A sample of bacterium has a mass of 2 femtogram. Express this measurement in terms of grams. We want to express this in terms of grams. We want to express in terms of gram and kilogram. So what the given? The bacterium has a mass of what the given? We know that the mass of the bacterium is what? This is the same as 2.0. This is the same as femtogram. So what we want is, we want to express this in terms of gram and kilogram. Let's do it. We know that femto is a prefix which belongs to 2 times 10 to the power of negative 15 gram. Actually, this needs your mathematics. It needs some kind of mathematics background. Femto is I convert this prefix femto in terms of power of 10. I express it as a power of 10. So 2.0 I can write as 2 multiplied by femto from our previous table. Femto is, as you can see it here, femto is a prefix which equal to 10 to the power of negative 15. So this is what it means. So we already changed it to gram. Already it's given in grams. So the mass in gram, if you are asked to write the mass in grams, the mass will be 2 times 10 to the power of negative 15 gram. The problem is, how do you write this in kilogram? Now here comes the problem. Here is the problem. What you have to do is try to express this 10 to the power of negative 15 as a power of 2 numbers. Let me show you. I can write 10 to the power of negative 15 as, this can be written as 10 to the power of negative 18 multiplied by 10 to the power of 3. I can. This, we get this from the rule of exponent. If we have like a to the power of 2 multiplied by a to the power of 3, when you are asked to multiply these numbers or these exponents, what you have to do is make sure that they have the same base. Do they have the same base? Yes, they have the same base. So what you have to do is, from the rule of exponent, you take one of the 2 bases, that's a, and add the exponents, that's 2 plus 3. So this is equivalent to is a to the power of 2 plus 3 is 5. So using this rule, let's check this one. Let's check whether this is correct or not. Let's check 10 to the power of negative 18 multiplied by 10 to the power of 3. What does it give me? Let's check it. Now, do they have the same base? They have the same base, yes. I will take 10 and add the exponents. Negative 18 plus 3. And this is the same as 10 to the power of negative 18 plus 3 will be negative 15. So This mass is now equivalent to the mass of the bacterium is equivalent to, instead of this 10 to the power of negative 15, I can use this multiplied by 10 to the power of negative 18 multiplied by 10 to the power of 3 gram. I have gram, and I know that 10 to the power of 3 is a power that belongs from our previous lesson. For our previous table, we have stated that we know that 10 to the power of 3 is a number which belongs to kilo. So instead of this 10 to the power of 3, I can use the prefix kilo. So this mass is now equivalent to 2 multiplied by 10 to the power of negative 18. Instead of this 10 to the power of 3, I can use kilo. Then I have G. Now it becomes kilogram. That is how we find the mass of this bacterium in terms of kilogram. That's all what we have for today.